The given data, secant AB and tangent AC intersect at point A on circle O. This is the figure, and this is the secant AB, and this is the tangent AC. This is circle O. The center of the circle is O. This is the point of tangency, point A. It is at this point that the secant and the tangent intersect. We are going to prove that the measure of angle BAC is equal to 1 of the measure of arc AB. This is the angle BAC, and this is the arc AB. Well, we are going to prove that the measure of this angle is 1 of the measure of this arc of the circle. We are going to prove the theorem by using a two-column proof. In the first column, we are going to write the statements, and in the second column, the corresponding reasons. For our first statement, secant AB and tangent AC intersect at point A on circle O. The reason given. These are the given data. Next statement, we are going to draw diameter AD and chord BD. Let us draw the diameter. This is diameter AD, and this is the chord BD. The reason by construction, line postulate. According to the line postulate, we can only draw one and only one line through two points. Let us name this angle 1, this angle 2, and the third one angle 3. Next statement, arc ABD. This arc ABD is a semicircle. The reason, definition of semicircle. Next statement, angle 3. This angle is a right angle. The reason, an angle inscribed in a semicircle is a right angle. This is the Thales theorem. Next statement, the measure of angle 3 is equal to 90. If angle 3 is a right angle, then the measure of angle 3 is equal to 90. The reason is definition of right angle. This is the copy of the figure. In this figure, we can see that ABD is a triangle. If this were a triangle, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Let us write that as our next statement. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. The reason, sum of angles of a triangle is 180 degrees. In step number 5, we said that the measure of angle 3 is equal to 90 degrees. So we can substitute 90 for measure of angle 3. So we have now, for our next statement, the measure of angle 1 plus the measure of angle 2 plus 90 is equal to 180 degrees. The reason, substitution property. Let us subtract 90 from the left side. Now, if we subtract 90 from the left side, we must also subtract 90 from the right side. So, for our next statement, we have the measure of angle 1 plus the measure of angle 2 is equal to 90. We subtracted 90 from both sides of the equation. So the reason, subtraction property of equality. For our next statement, tangent AC, this one, is the perpendicular to OA, segment OA. Segment OA here is the radius of the circle. According to this theorem, this is a theorem, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. This line AC is tangent to the circle. So it is perpendicular to radius OA that is drawn to the point of tangency. The point of tangency here is point A. Next statement, angle DAC is a right angle. If this tangent line is perpendicular to the radius, or the radius is perpendicular to the tangent, then this is a right angle. The reason is definition of perpendicular. Next statement, if this is a right angle, then its measure is equal to 90. Now, we can add the angle 2 to angle BAC. Angle 2 plus angle BAC is equal to angle DAC, which is the right angle whose measure is equal to 90. Therefore, the measure of angle 2 plus the measure of angle BAC is equal to 90. The reason, angle addition postulate and definition of right angle. Now let us look at step number 8 and step number 11. The right side here is 90 in step number 8, and the right side in step number 11 is also 90. So the right side is equal to the right side, so the left side is equal to the left side. So for our next statement, the measure of angle 1 plus the measure of angle 2, this one, is equal to the measure of angle 2 plus the measure of angle BAC. This is the left side of step number 11. The reason, transitive property of equality, steps 8 and 11. This is our statement number 12. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle BAC. Let us subtract the measure of angle 2 from the left side and then subtract it also from the right side. The result is the measure of angle 1 is equal to the measure of angle BAC. Let us write that as our 13th statement. The measure of angle 1 is equal to the measure of angle BAC. The reason is subtraction property of equality. Let us look at the figure. This is angle 1 and this is arc AB. So for our next statement, the measure of angle 1 is equal to 1 of the measure of arc AB. The reason is inscribed angle theorem. According to this theorem, the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. This is the intercepted arc. And angle 1 is the inscribed angle. For our final statement, the measure of angle BAC is 1 of the measure of arc AB. The reason is transitive property of equality. Look at the statement number 13 and 14. This is equal to this, so this and this are equal.